More about power steering in Chapter 28. As vehicles became heavier in the front end due to the increased use of front-wheel drive and wider, low-profile tires, more steering effort became necessary. As a result, power steering was introduced. One type has an engine-driven hydraulic pump that delivers hydraulic fluid to the power unit in the steering box or rack and pinion assembly through connecting hoses and pipes. When the driver moves the wheel, the hydraulic pressure is sent to the rack or steering box. The power steering system is designed so that the vehicle could still be controlled even if the engine or the power steering system were to fail, through greater effort would be required. There are three types of power steering: hydraulically assisted power steering, electrically powered hydraulic steering, and fully electric power steering.
With heavier vehicles, increased use of front-wheel drive, and wider, low-profile tires, more steering effort is needed, so power assistance is used. A hydraulic pump is driven from the engine to provide pressure to help the driver. The power steering system is designed so that even if the engine or the power steering system fails, the vehicle can still be controlled. However, much more driver effort is required.
I just said that. Hydraulically assisted power steering uses hydraulic fluid under pressure to assist the driver in steering the wheels. The design is especially helpful at slower vehicle speeds when steering wheel turning effort is much higher. An engine-driven hydraulic pump delivers hydraulic fluid to the power unit at the steering gearbox or rack and pinion assembly through the control valve and connecting hoses and tubes. The fluid reservoir can be mounted on the pump, or it can be remotely mounted. When the engine is with the engine running, fluid flows continuously from the power steering pump to the steering gear control valve and back to the power steering pump. With the steering wheel in neutral position, minimal pressure is needed to maintain fluid flow, and minimal engine power is needed to operate the system. Some manufacturers task the power steering system with double duty. The pressure from the power steering pumps has been used to power hydraulic brake boosters on Hydro Boost vehicles. It has also been used to turn the radiator fan on a number of vehicles, which is weird. I've never seen that before. Be aware that the power steering system is integrated in those systems on some vehicles. The hydraulic fluid and power steering system transmit pressure from the power steering pump to the working chambers in the power steering gear or rack. The fluid must withstand high temperatures and pressures and at the same time lubricate the pump and steering gear while preserving the system seals and pressure hoses. The fluid must flow freely on very cold temperatures. Hey, when they're talking about all this power steering pump to the working chambers and the power steering gear, it's all about ASC when you guys when we start talking about it, okay? Because when you go to the shop, you really don't check the chambers. You don't break them apart anymore. We replace the whole unit when the unit goes bad, so we don't have to take it apart anymore. But this is going to go in a little deep. If you guys don't understand it, it's okay. You don't really have to. Just remember they're for ASCs. Now the power steering hoses are used to carry power steering fluid from the pump to the steering gear. This is a high pressure hose and is usually made out of flexible high pressure hose material. That is what usually leaks in a system, is that high pressure hose. The return hose runs from the steering gear back to the pump reservoir and carries fluid under much lower pressure. These hoses must also allow movement between the engine and the chassis so they can't be too stiff. The hydraulic pressure is controlled by a rotary valve located in the input shaft of the steering gear. When the steering wheel is turned, the rotary valve directs the fluid to one side of the other piston attached to the steering gear. Pressure then increases as required to provide steering assistance. In the rack and pinion steering gear, the piston is formed centrally on the steering rack and the rack housing provides the working cylinder. The pressure seals at each end of the cylinder isolates the power section from the rest of the rack and pinion. Seals in the rotary valve section at the pinion input prevent internal and external fluid leaks. So most of the pumps The hydraulic pumps are rotary vane type, and this is what the rotary vane type looks like. In a recirculating ball steering box, the power piston and seal slide in the cylinder housing. The power piston has an extension formed on one side with teeth that engage teeth on the sector shaft. Pressure applied to either side of the power piston produces a force which is transferred to the teeth to help turn the sector shaft. With the engine running and the steering in the neutral position, fluid flow is directed into the valve assembly through drilled holes in outer sleeve. I was about to say holes. Drilled holes. As soon as the steering is turned to the left or right, a slight relative movement occurs between the inner and outer members. All power steering pumps have a flow control valve to vary the fluid flow and power steering system pressures. A pressure relief valve prevents excessive pressures from developing when the steering is on full lock, which is turned all the way to one side, and is held against it stops in that position. The flow control valve is located in the outlet fitting of the power steering pump and regulates pressures to as high as 1,200 to 1,500 pounds per square inch. When the flow control valve is forced open and steering stopped, there is usually an audible whine from this very high pressure. The movement of the control valve controls the position of the needle valve in the outlet fitting. This controls the fluid flow to the steering gear. When the valve moves and then covers the return port to the pump inlet, the flow control valve steering wheel will be at full lock. When maneuvering a vehicle at slow speeds, the power steering demand will be high and the engine speed will be low. If the idle speed is not maintained during this condition, the engine could possibly stall. To prevent stalling, engineers program the strategy into a PCM that raises or maintains the idle speed under these conditions. A power steering switch or a sensor inputs power steering pressure information to the engine control module. And based on the input and the actual engine idle revolutions per minute, the PCM is able to determine when additional airflow is needed to raise or maintain the desired engine RPM.
Increased applications of front-wheel drive and wider low-profile tires places additional loads on front wheels. Steering then demands more effort from the driver. Power steering helps to reduce the additional effort needed. It's of most benefit during slow cornering and when parking. Assistance is provided as soon as the steering wheel is rotated in either direction, and it's designed so that even if system failure occurs, the vehicle can still be steered. An engine-driven hydraulic pump delivers hydraulic fluid to the power unit at the steering box or rack and pinion through connecting hoses and pipes. The fluid reservoir can be mounted on the pump, or it can be separate. With the engine running, fluid flows continuously from the power steering pump to the steering gear and back to the pump. With the steering wheel in the neutral position, little pressure is needed to maintain fluid flow, and little engine power is needed to operate the system. When the steering is turned, a rotary valve, integral to the steering input shaft, directs fluid to one side or the other of a piston attached to the steering gear. Pressure then increases as required to provide assistance. In a worm and roller steering box, a piston slides in a cylinder in the casing. It has an extension formed on one side with teeth that engage teeth on the pitman shaft. Pressure applied to either side of the piston produces a force which is transferred through the teeth to help turn the pitman shaft. In a rack and pinion steering gear, the piston is formed centrally on the steering rack, and the rack housing provides the working cylinder. Seals at each end of the cylinder isolate the power section from the rack and the helical pinion. Seals in the rotary valve section at the pinion input prevent fluid leakage there. Connecting pipes transfer fluid from the rotary valve housing to one side of the piston or the other to provide assistance, which acts directly on the rack. The rotary valve is located between the steering gear input shaft and the pinion gear. It consists of an inner member, which forms part of the input shaft, and a surrounding sleeve member fixed to the pinion gear. Turning the steering wheel makes both members rotate in the steering gear housing, but it is the slight relative rotary displacement of the inner member and the sleeve member which controls and directs the power steering fluid flow. This slight rotary displacement is allowed by a torsion bar, which is connected to the pinion gear at its bottom end and the input shaft at its top end. When the steering wheel is turned, there is resistance from the front wheels at the road surface. The resistance is transmitted through the rack to the pinion gear so that the input shaft twists slightly on the torsion bar. Since the inner member is also attached to the input shaft, this twisting provides a relative rotary displacement of the inner and outer members. It is this displacement that lets fluid flow through the valve to act on the piston at the steering gear. The input shaft can twist through only a small angle before it contacts a stop on the pinion gear. This is needed to provide manual steering when power assistance is not available. With the engine running and the steering in the neutral position, fluid flow is directed into the valve assembly through drilled holes in the outer sleeve. As soon as the steering is turned to the left or right, the slight relative movement occurs between the inner and outer members. In the neutral position, the inner member lets fluid pass equally to both sides of the rack piston and return to the fluid reservoir. Equal pressure is applied to both sides of the rack piston. No power assistance is needed. When the steering is turned, fluid is restricted from making a free return to the reservoir. It is now directed to the side that matches the turning action. At the same time, fluid on the opposite side